Is horseshoe magnet, right? From the set. The question is, the pole strength of a horseshoe magnet is 90 ampere meter. The distance between the poles is 6 centimeters. Let's say this is nothing but this is 6 centimeters, but you consider this is in the horseshoe magnet will be in the form of semicircle. Usually it will be like if you see like this kind of structures actually, right? But you consider for understanding simply understanding purpose, it is a semicircular shape. So this will be a diameter of the circle. That's diameter of the semicircle. Now, the magnetic induction, you're asked to find the magnetic induction at the midpoint of the line joining the poles. This is one pole, this is south pole, north pole. Magnetic induction of this is the line joining the poles, midpoint of the line joining the poles. This is diameter. Then we have to consider that to find total magnetic field, we have discussed one simple point. Magnetic field due to single pole is m0 by 4 m by r square. Let us say if its pole strength is m1, m1 by r1 square if its distance is r1. Due to this, it is what is that? M0 by 4.2 m2 by r2 square. But usually pole strengths will be equal. Pole strengths will be equal. So if and this radius is nothing but d by 2. So by using this, you can say magnetic fields due to those two poles is nothing but due to total field is equal to field due to the first pole plus field due to second pole, where m1 by r1 this is m0 by 4 m1 by r1 plus m2 by r2 squares. So as this m1 m2 are equal and r1 r2 is also equal, then you can take it as 2m by r square, but r is nothing but in terms of diameter d by 2. So here you can take it as a d by 2 r square, or directly as a numerical values are given, you can substitute and you can find out this. But as a formula form, if you want, you can take it as d by 2 whole square in terms of diameter if you want. This d square by 4, it becomes 8, this 4 into 2 becomes 8 m by d square, divided by 4.8 m by d square. Here d is given directly 6 centimeters and the pole strength is given as 90 ampere meter. So that 6 centimeters you have to convert into meters. Also be in SI units. So that conversion you have to do properly. That's it.
So the both two poles are same radius. The radius are same.
Same we consider there is the same, I mean the distance.
So the
The distance is same. At midpoint you are asked to find, right? So whatever this distance, this is the distance also the same. Midpoint means it is a diameter. So radius. Radius of a semicircle. Got it?
yes.
20, 21. moment of the magnetic moment. So what is given here is question number 20. The question is the force acting on each pole of a magnet when placed in a uniform magnetic field of 7 ampere per meter is 4.2 into 10 power minus 4 Newton. If the distance between the poles is 10 centimeter, the moment of magnet is, or moment of magnet means magnetic moment is. So let's see what is this once again. The force acting on each pole of a magnet. So let us consider a bar magnet. Magnet means bar magnet, north pole and south pole. Both will have magnetic moment, pole strengths M and M. The force acting on each pole of a magnet when placed in uniform magnetic field. This is placed in uniform magnetic field. On each pole, force acting on each pole is F is equal to how much? 4.2 into 10 to the power minus 4 Newton, provided the pole strength of this each pole is M is equal to how much? 7 ampere per meter. Both will have same what you call magnetic strength, but one should be positive and the other should be negative. If the distance between the poles is the distance between the poles, this is nothing but actually our 2L. It is what effective length, not the geometric length. 2L is 2L is 10 centimeter. Then moment of magnet is what? Moment of magnet is what? So we know force. It is kept in a uniform magnetic field, right? Magnetic field is given. Magnetic field strength is not given, right? It is kept in a uniform magnetic field. Uniform magnetic field, perpendicular or parallel direction, that is not mentioned here anyway, is kept in uniform magnetic field, right? So let us consider the force on a given pole due to external uniform magnetic field is M into pole strength into the strength of the magnetic field. Strength of the magnetic field. But here um, pole strength is given, but magnetic field is not given, right? The uniform magnetic field is not given. So how can you consider this uniform magnetic field? Because here force is also given. This is also given. Oh, okay. So and you are asked to find magnetic moment. So we can say from this magnetic field is given by, this implies magnetic field B is equal to F by M is equal to 4.2 into 10 to the power minus 4 by pole strength is 7 ampere per meter. Let us keep it as it is. But we are asked to find magnetic, what is that? Dipole moment. What is that? Moment of magnet. Moment of magnetic means a dipole moment of magnet. That is capital M is equal to, for a bar magnet it is M into 2L, right? Oh, M into 2L directly given, right? But for a bar magnet it is M into 2L, not in that way. Moment of the magnet. Moment of the magnet, but in terms of here, 10 minus 4. So as per this should be what to consider all those things. Actually here they like, can also say by using this itself we can also represent this as force is equal to, as we know, And in terms of moment of magnitude, you can write it as from this, but actually from this you can calculate. But so we can say, let us say m is equal to m by 2l, right? M by 2l, and mm, m by 2l, then you can express the force is nothing but m by 2l into b. We want this. This actually, this is not this is only right. Okay, next you can say pole strength. What is this given here? Magnetic when placed in uniform magnetic field of oh, force acting on each pole of the magnet when placed in uniform magnetic field of 7 ampere meter. Magnetic field of 7 ampere meter. This is not this thing, right? This we have taken wrongly. That's why this by looking at this is just confusing. So this is magnetic field of this much. Magnetic field of 7 ampere per meter. So ampere meter is constant. Ampere per meter is magnetic field is given. So we're supposed to find out this by what is that magnetic moment. How to find magnetic moment is because small m is given, then you can calculate this. But small m is not given. By making use of this, how to find it is b is given, f is given, 2l is given. This you can substitute now. But actually speaking, a magnetic field strength, uniform magnetic field of 7 ampere meter is given. Is this magnetic field strength or magnetic field intensity? Uniform magnetic field only, right? Ampere meter, ampere per meter. So that is the case. From this you can say capital M is equal to F into 2L by B by B. F is 4.2 into 10 to the power minus 4 by 2L is 10 into 10 to the power minus 2. B is into 2L. Okay, 2L is here. This is 2L. 10 into 10 to the power minus 2 by mm, B 7. So 7 6 is 42. So can we say point 6 point 6? So it is equal to, so it's 0.6 into 10 power minus 4 or 6 into 10 power minus 5. This you can write it as 10 power minus 1, 10 into 10 power minus 2 is 10 power minus 1, 6 into 10 power minus 5 minus 1 is 10, 6 into 10 to the power minus 6. As given as question 20, right? First option is given 15 by pi 20. I think this terminology they have used in a different way. If it is magnetic field, you will get this only. If it is magnetic field, but if it is magnetic field intensity, there is, we have to use a different term. This is the thing. It's okay. What is this M? M will be magnetic moment will be unit of magnetic moment will be ampere meter square. Ampere meter square. But here, this terminology have it is given clearly given that it is given that is B magnetic field. If it is magnetic field intensity, we have to use this as H. H is equal to 7 ampere per meter. I think they have taken this as a magnetic field intensity, not as a what do you call it, field. So actually there are some confusing terminology will be there. Strength of the magnetic field intensity, this kind of terms. You have to be a little careful about in this special in this chapter actually. If this is the case, here this B you have to replace with H, and B is equal to mu naught H you have to take. That form you have to take, then you will get a different answer. In such case, if you take this is B, you will get this one. But in terms of this, if you want, if this is H, no, H is equal to mu naught B. B is equal to B is equal to mu naught H, mu naught H. hmm, B is equal to mu naught as because this is the one. If H is this, then you have to take it as 7 mu naught. 7 mu naught is B, and here this will be 7 mu naught in place of B. What you have taken? Where this is B, right? 7 mu naught. B should be 7 mu naught. Then this will be by mu naught. By mu naught, right? So if that is the case, then what should be mu naught is 4 pi into 10 to the power minus 7. 6 by 4 pi 6 into 10 to the power minus 6 by mu naught is 4 pi into 10 to the power minus 7. Minus 6 cancel, minus 1 remains here. So it is 2 threes, 2 twos. So it would be 3 by 2 pi 10 power minus 1. If it goes here, it becomes 10. So it becomes 2 fives. So 3 fives is 15. 15 by 5 it will become. So that means here the terminology you have to be very careful. This magnetic intensity is supposed to be not this one. It is supposed to be H. H is given means B should be equal to mu naught H. Then you have to take it as 7 mu naught. Then you will get this one. So according to this, we have to say then M is equal to 15 by pi. Then obviously unit should be ampere per meter square only have to take. Okay. So the terminology what they have given is uniform magnetic field of 7 ampere per meter only. Hmm? Magnetic field B, what you have taken in different forms, right? So that unit magnetic field can be taken as Newton per F by from the definition of magnetic field. We have discussed it together, right? Magnetic field as B is equal to F by M. So Newton per, this is ampere meter. Huh? Here it is ampere per meter means it is suppose you have to think about the units also. That means this is ampere per meter, or can also take it as Weber per meter square or Tesla. If that is the case, you have to rethink. You have to think that if it is B is equal to mu naught H from Biot-Savart law, what is this? B is equal to mu naught by 4 pi into I dl sin theta by r square, right? From this you can say unit of mu naught. Unit of mu naught will be b r square by ideal. So here is ampere. This is meter square. Meter cancel will be meter. So it will be Tesla meter per ampere. Tesla meter per ampere, right? Yes or no? So this is given as the value is given in terms of ampere per meter means. So that is we suppose it to be this one. So mu naught is this, but B is supposed to be Tesla. So if you take this as total value is in ampere per meter means, so you have to think that if it is mu naught H, mu naught H, then B is Tesla. Okay, that means H is equal to B by mu naught. So it is a Tesla. This is Tesla meter per ampere. So Tesla cancel. You get ampere per meter. Ampere per meter is nothing but unit of H, not of B. So that you should understand by observing uh, this representations. As H is equal to B by mu naught, its unit is ampere per meter, not B unit. So from this you have to realize this. Even though it is given as magnetic field of 7 ampere per meter means it is H. So Right. Which one?
12 something.
With the opposite. So the question is three magnets of same length but moments in 3M are arranged in the form of equal triangle with opposite poles needed. Um, the resultant magnetic moment of the arrangement is.
Here formula.
So what you have to understand here is so what is given here is three magnets of same length but moments m, 2m and 3m are arranged in the form of an equilateral triangle with opposite poles nearer. The resultant magnetic moment of the arrangement is. So equilateral triangle. Let's consider equilateral triangle. Equilateral triangle. Right. It is mentioned that three magnets of same length but moments same length same length but moments are different means pole strengths are different, right? So this is one magnet, this is another magnet, this is another magnet, so that for same length and magnetic moments are arranged in the form of an equilateral triangle with the opposite poles nearer. Opposite poles means let us say this is south north. For first one S1 N1. Next this is another magnet, second magnet, right? So that opposite poles nearer means it is not means for this it will be south S1 S2 N2 for second one S2 N2. Next this is another magnet, so that opposite poles nearer, this is not means the south of the other will be nearer, so S3 N3, that is the meaning of opposite poles are nearer. They are arranged in equilateral triangular form, so that this magnetic moment is first magnetic moment of the first one is m1. Let us say this is from south to north, magnetic moment in direct, right? This is m2. For this it is in this direction m3. So it is given that m1 is equal to m and m2 is equal to 2m and m3 equal to 3m. M3 is equal to 3m. Fine, 3m. The question is what is the net resultant magnetic moment of the arrangement? We have to, this is equilateral triangle means the angle, so you have to, you can say this is identical to three vectors acting in this direction. With this sides are 60 60 60, that is one thing. This can also be expressed as this is one vector m1 vector, uh, if magnetic moment is here, this is another vector, this is another vector m2 vector of magnetic moment 2m. So but to find the resultant of this two, this is 60 actually, but you have to arrange this in such a way that second vector have to shift without changing the magnitude and direction, so that the what do you call tails of the both will coincide. So then this will be theta. Smaller angle. This is one angle. This is also angle between them also. But shorter angle will be theta. Theta is nothing but what? This is 60, but this is 180. 180 minus 60 is this is 120. This is the angle, nothing but angle between the two vectors. That is 120. So now resultant of this two, you tell me. Resultant of this two, you can say only for this two is first resultant is equal to square root of m square plus m square plus 2m1 m2 cos theta. M1 square is m. So m square plus 2m whole square is 4m square plus 2 m1 m2 m into 2 m into 4 4m square into cos 120. Cos 120 is how much? 1 minus 1 by 2. So 2 2's. So minus 2m square. Right? So 4m square minus 2m square is 2m square. 2m square plus m square is 3m square. So it is root 3m. Root 3m is the resultant of these two. But what is the direction of this? In this direction. Did you understand? This direction means you have to find that angle also. That is alpha. Alpha in this direction means the same direction or what? So you have to consider alpha is equal to tan inverse of with respect to m1 it is m2 sin theta by m1 plus m2 cos theta. So it is equal to tan inverse of m2 is 2m sin theta. Theta between these two is 120. Sin 120 is sin 90 plus 30. Sin 90 plus 30 means cos 30. Cos 30 root 3 by 2. So root 3 by 2, 2 to cancel, it is root 3m by m1 m plus again m2 cos 30, cos 30 only, huh? No, cos 120. Cos 120 is minus.
Sin minus sin 1. Minus sin 30.
Hmm.
Minus 1 by 2.
Minus 1 by 2. So m is 2m. 2m by 2. So it is, oh, what is this?
Sir, it will become 0.
m1 plus m2 cos 120. Cos 120 is how much?
Minus 1.
Minus 1 by 2 only.
Yes, sir.
Hmm? M2 is 2m.
Yes, sir.
2m. Hmm? Okay, it is infinity. 1 by infinity. So for what value of this is infinity? 90 degrees?
Sir, yes, sir.
Tan 90. So it is tan inverse of infinity means alpha is equal to 90 degrees. Sir. Oh, alpha is 90. Then alpha is 90 means this the angle between this and this, that means this is the direction of this resultant, not this one. This is resultant one, right? So this is the resultant, okay, but this is with respect to the horizontal, this is what, 60, huh? But with respect to horizontal this is 90. So angle between these two will be
30.
provided, you have to be careful here, this is in upward direction, this is downward direction.
Yes, sir.
So the angle between them, if you want to consider, we have to extend this shorter angle you have to consider. So little just you have to take little carefully, and you have to just take it. What you are asked to find the magnitude only, right?
Yes, sir.
So only magnitude, right? You need to worry about the direction. Only this magnitude you worry about. Oh, what is the angle between them? So this is the one. Hmm? You have to say this is perpendicular direction, and this is this direction. Okay, this is 60, this is 90, 90 minus 60 is 30. So this is m3, this is resultant 1, m resultant 1, this is m3, right? Now to find the actual angle you have to extend this so that tails will coincide. Now if you, this is the one, what is the, this is a shorter angle between them. Hmm?
Yes, sir.
So actually this is supposed to be 180.
180 minus
180 minus 30 is 180 minus 30.
180 minus 30.
150. One. This angle will be 150. Is the angle between this and M3. So now resultant, final resultant is square root of this magnitude is what? Root 3m. Root 3m whole square. Square root of root 3m whole square is 3m square. 3m square. 3m square plus this is m3 is 3m. 3m square is 9m square. 9m square plus 2m1 m2. 2m1 is root 3 m. m2 is 3m. Yes, 3m into cos theta. Cos 150. Cos 150 is 180 minus 30. 180 minus 30. So minus 30. Minus cos 30. Minus cos 30 is
Cos of minus theta, cos theta, sir. Cos 2.
cos 30. Cos theta only. Minus cos 30. Root 3 by 2.
Yes, sir.
Minus root 3 by 2. Second quadrant. 180 minus theta means second quadrant. So it is negative. So minus 1 by 2 will get. Minus root 3 by 2. Minus root 3 by 2. Minus. But minus. So we will get 2 to cancel. Root 3 into root 3. 3. 3 into 3. 9m square. Minus 9m square. Minus 9m square plus 9m square cancel. 3m square. It is root 3 m. Is there any such option?
Yes. Yes.
Try it one. Root 3m. Yes, that is the correct one. That is the final result. That is the final result. Okay. So just you have to understand this carefully. This angles. This angles have to take a little carefully.
So what is it? NN
Yes.
அப்புறம் வந்து அது வந்து it is perpendicular to the
Which one? So what is given here? A magnetized wire of magnetic moment M and length L is bent in the form of a semicircle of radius R. Question number 4. A magnetized wire of magnetic moment M. Magnetized wire means it is acting like a magnet, bar magnet, right? Magnetized, this is a wire, it is magnetized, so it is acting like a magnet now. Let's say it is the south pole, north pole of the wire. So that its magnetic moment is M. Hmm? M1 is M. It is and magnetic moment M and length L. Its length is L, right? Now it is bent in the form of a semicircle of radius. This is bent in the form of semicircle of radius R. R. Okay, fine. A semicircle of radius R. The new magnetic moment is, so new magnetic moment, let us say M dash is equal to what? M dash, capital M dash, magnetic moment, it is equal to pole strength. Let us say its pole strength is M into its usually magnetic moment is equal to pole strength into magnetic length. Magnetic length actually. Uh, so, but it is given as length of this magnetic geometric length is this L, right? This is geometric length. So, otherwise you have to take it as M dash is equal to M into magnetic length. Magnetic length. Hmm? New magnetic length. Let us say M dash into 2L dash. M dash into 2L dash. That is M dash 2L dash is nothing but magnetic length of the new one. So this is the south pole. Then this is north pole. This is the magnetic. What do you call this thing? What is that thing? Magnetic length. Effective magnetic length is the shortest distance between them. So, but here geometric length is given. Sorry, Manu? Say it again. Yeah. So we can say here this new magnetic length is nothing but in terms of this L is a geometric length actually. In terms of geometric length, we know you know what is this 2 pi r is circumference, but pi r is circumference in this case. Pi r total L is nothing but pi r. Here r is L by pi, but here 2r is 2r is magnetic length. So magnetic length is in this case new magnetic length is 2r. This is equal to 2 into what is this L by pi is new magnetic length, but pole strength is not changing, is same only. Yes. So because nothing, you have bended, so that means pole strength will not, area will not change, and hence this is south north only. So it will be M only. M into new magnetic length is nothing but 2L by pi.
2L.
Sorry,
Pi R.
pi
Pi R.
L is pi r. So
Then
r
R
is
is equal
equal
to
to
2
L
into
by
L.
pi. This is L by pi. So 2r is equal to 2 into L by pi. 2 into L by pi. By new magnetic moment you are asking to find in terms of old magnetic moment. Here, what is old magnetic moment? I have to say old magnetic. This is geometric length. Here, initial magnetic moment is nothing but m into magnetic length. So it is equal to, magnetic length is equal to 5 by 6 times geometric length, right? So m into 5 by 6 times L. Hmm? 5 by 6 times L. So or this is m. But here there is no 5 by 6 form. No? That means they are taking this L as it is, as L as magnetic length only. There is no 5 by 6 thing. Okay, ml is m. So we have to take it as if you take it here, ml is m. So it is 2m, 2 capital M, 2 capital M by pi, 2 capital M by pi, 2 capital M by pi, pi. Oh, but again they have taken pi as L by R form. Something like this. There are
Yes,
pi
sir.
forms are there, but it is not there. One more other different form is that they have to
Pi
cross
is
check that
equal to
also.
R by
Actually,
L.
yeah, actually this is correct one. M dash but this is not there. That means you have to cross check, can you express this in terms of other parameters or not. So m dash can also be expressed as 2 into what is this?
Pi is
Here
equal
pi can be expressed as L by R. So 2m by pi can be taken as 2m by pi is L by R. So 2mr by L. So 2mr by L also can express.
yes, sir.
So that is how you have to cross check fourth one.
Yes.
2. Okay, depending on the options, you have to simplify. But this is correct, it is there, this is correct. It is not there, that means you have to simplify further by looking into the options.
This question.
Seventh one.
Okay. A bar magnet of magnetic moment M, magnet of moment M is bent into shape S. If the length of each part is the same, its new magnetic moment will be. Hmm. So, so how to consider this? Let us see. Question number 7. Question number 7. So the question is, a bar magnet of moment M is bent into a shape of S. If the length of the each part is same, the new magnetic moment will be. It is given as like this S shape. S shape, and one more thing is given that if the length of each part is same, that means this is S shape. Yes, this is one, this is another one, this is the one, right? This is another one, and this is another wire. This is S shape. So that you say this is one wire, one magnet, another one, the second part, third part, fourth part. So that length of each part, one, two, oh, this is three. Okay, three, four, five. Five parts constitute this. So each part length is same. Got it? So what is this? A bar magnet is bent into this form. That means it is bent into five equal parts. Five equal parts means the area is not changed. So magnetic moment pole strength will be same only. Only effective length is changing. So the divided into five equal parts means initial magnetic moment. If you have a bar magnet, if you have a bar magnet with the south pole or north pole, you'll say it's if its magnetic length is 2L with dipole strength M and M, then it's M1 can be taken as M, right? But when it is bent, then the new magnetic moment you can take it as M dash. M dash is what? M dash is equal to what? What did we discuss? It is bent in a different forms. So you have to take it as actually this is nothing but pole strength into 2L. Pole strength into 2L. But here pole strength is same. So M dash is equal to new pole strength into new magnetic length. Pole strength is same only because the area is not changed when even though when you bend M is same, M dash is same. But what is 2L dash? 2L dash, new magnetic length. If it is bent into any shape, a semicircular shape or any other shape or U shape or whatever it is, effective length, the shortest length between what do you call south pole and north pole. This is your magnet. You have bent like this. This is the magnet. You have bent like this, right? Now this is your south pole. This is your north pole. The shortest distance. So what you have to consider here is just draw some dotted lines. This is one dotted line. This is one dotted line. Got it? So this is, let us say, L, right? It is equally it is bended into, right? This is capital L is 2L. Let us say this is some X, hmm? And this is also X. This is also X. So this side length is nothing but how much? 2X. So this is X. So it is a right, what you call, rectangle. Got it? So in case of a rectangle, the shortest distance between S and L is nothing but a diagonal. This is nothing but our 2L dash. So here, this is our 2L dash. So what is 2L dash if you know this? Yes, 2L dash is nothing but what you call diagonal of rectangle. So what is diagonal of rectangle? Is if we can take this as a right angle triangle. So hypotenuse of a right angle triangle. So square plus side square. Hmm? Yes, that means in terms of L you want, right? So this is L, this is L plus L 2L, L 2L. So L square plus 2L square, L square plus 2L square is 4L square, right? So this square is equal to 5L square, but this side is equal to square root of this. So it means
So
root
root 5
5L is 2L dash. So it is root 5L. Did you understand how to get this? Then this is m into 2L is m. In terms of m into 2L, if you want, you have to multiply this both numerator and denominator with 2 by 2. So you can this further, you can write this as m into 2L, m into 2L, right? Into root 5 write down separately root 5 by 2, but m into 2l is m, so now this can be expressed as root 5 m by 2 is new magnetic moment. So new magnetic moment m dash is equal to root 5 m by 2. Is there any such option?
No,
Root 5.
So we can take root 5 as first n by 5, n by 5, n by 5, n by 5, n by 5. Then after that only we
Say
can take this.
what is that? What is that?
So when we are bending in the shape of U, sir,
Hmm.
we take it as L by 3, L by 3, L by 3 because it is in equal parts and it is in three parts.
Hmm.
If the length is changed, there is 2 L by n only, sir.
Yes.
The
Yeah, also you
formula
can
is
take L by 5. Yes. You can take what is so this is L by X. Oh, here we have taken
yes, root 5.
okay, this is
It should come in
L by
denominator, no, sir.
5. This is L by so this X is L by 5, not
L by
L.
5, yes, sir. L
Yeah,
by
yeah, yeah.
5.
We have taken L, right?
Yes,
L
sir.
and 2L. That is wrong. So it is L by 5.
Yes, sir.
So L by 5 square by L by 5 square plus this 2L by 5 square. That's small mistake again. So this 2L dash is this one. This is nothing but square root of L by 5 square plus 2L by 5 whole square. It is equal to L square by 25 plus 4L square by 25 under root. This can be expressed as L square by 25. We take it as 1 plus 4 is 5 root 5, right? So 5 by 5, 5 by 25 is 1 by 5. So L square by 5 will get. That is L by root 5 will get. Root 5 is 2L dash. L by root 5. Yes, yes, that's not root L. This is a small mistake. So now this is what is that? L by root 5. This is not the this one is L by root 5. So everywhere you have to just simplify this. You have to just do a small simplification. So it is L by root 5. So this is L by root 5. But we know M into 2L is capital M. For that purpose again we have to do it. So this is M into 2L by 2 root 5. 2 root 5. Right? Yes. So we can say M dash is equal to M by 2 root 5.
So, no, sir, why do you have to multiply it with 2, sir?
So
Sir,
we
M
want
is
in
equal.
terms of M. M
Yes,
is
sir, M is
L
equal
by
to M
5, sir.
into L only, sir. Like, the 2 is not
okay,
just a
okay, just
constant, sir.
fine. We are taking as this is 12, but
Yes, sir,
this
this
is
is
L
L.
only, L
Yes,
only.
sir.
Yeah, yeah, yeah. So no need to do this actually in this one.
Yes, sir. So now it comes M
Yeah.
by.
So actually, this is L only. You have taken it is given L, but we have taken as this is 2L.
Yes, sir.
So that way this. So no need to complete this. So it is M into L by root 5. This is not 2L. This is L only.
Yes, sir.
M into L is capital M.
Yes,
So this then it is capital M by root
root
5.
5.
Capital M by
Root 5.
root
Yes, sir.
Second
Sir,
of
root 5.
sorry.
Yes. Yes, yes, yes.
Yes, sir.
That's it.
Thanks, sir.
Okay. Finished. Numericals. How many? Only six. Huh? The
Sir,
ones which work in class. Then extra.
that was the that was the task for the
Hmm. Reference, where is that? Can you check? Finished?
What use?
Finish before end of the day. Okay. Very good. Nice. Why so drastic change? Why so drastic change? Parents? Someone else? Hmm? Very good. Next I'm asking. Good inspiration. Keep it up. So all subjects are only physics. All should happen, huh? Especially biology. So what is today's date? Very good. Hmm? So we're aiming for NEET or something else. Final talk. NEET only. So that's your father's goal or mother's goal or yours goal. Sure. No, any other thing. Hmm? What is this?
Class.
Uh, if we have completed all from starting, huh? So when you have new book you have started, huh? What is your name? Write the name, section. Right, very good. Have you practiced by understanding? I can mention the units final for the final answers. Okay? Very good, very good. Nice. How many numericals? How many numericals? Final answer should be put in a box every time. Okay? Final answer should be put in a box. Okay? Very good. 6 4. Nice. What's your name?
Pooja.
Pooja. What's yours? Where is yours? Class. Finished? Finish if anything remains. And the other exercise 1. Exercise 1 also. Exact similar ones. I have to finish, I have to show me in the morning. Done. Take care. Yes.
Sir, after taking the result, sir, percent will pass through this or this one. So this one, sir. Check
Resultant of these two, first these two.
Yes, sir.
Resultant of these two
This
will
two
be,
will find result.
we consider this is first one.
Yes, sir.
This is second one. This is M. This is M you have taken.
Okay, sir.
You have taken this M, this is 2M, this is 3M. You have taken this M, this is 2M. So if that is the case, in that case, it will be perpendicular to M.
Which one, sir?
The resultant of M and 2M will be perpendicular to M. Yes, sir. This is M perpendicular to this. So angle between these two, angle between what do you call? This is 90, but actually you can say, where did we discuss this? See here, this is you have taken this you have taken as M1. This is M. This is 2M. This is 3M. You have
Okay,
taken.
sir.
M1 is M. M2 is 2M. M3 is 3M.
Yes,
With respect to, if the result of M1 2M will be the angle between the resultant of these two with respect to M1 is what is that? Tan inverse of infinity means alpha should be equal to 90. So 90 means here you can have drawn. Resultant of the first one is this one with respect to M1. So now this is this, but so this is the third one. This is the third one. Now we want the resultant. So this is so we have two vectors. Now we have two vectors. Simply you can write in a plane. This is one. This is another one is in the third side of the triangle, but in this direction.
Yes.
In this direction. So angle between these two we want, but this is tail, this is tail, this is head, this is tail head. At the head you cannot measure the angles. At the head you cannot measure the angles. So for that purpose we have just shifted from here to here, shifted from here to here. Now this angle will be the smaller angle will be the angle between this and this. The resultant of this first two and this. So that is, if this is a vertical line is 180, and this will be for this one. This is actually this is 180.
Remaining is
One in 180, if you subtract this 30, this one will be 150. This one will be 150. Actually, this is 180. In this 180, you have subtract this 30. This is the 150. That is the angle between this and this.
resultant and the
Third one, M3. So by taking that angle, you can find out new resultant. That is the root 3.
4, 6, 8, 9.
Other ones are finished.
Double 20.